geology, and good morning, good afternoon, good evening, whenever you're watching this. So I'm going to go over the laws of stratigraphy with you guys. So some of these laws you've already learned as a part of class, but there are some things I want to share with you. And at the very end of this video, we're going to do an example for one of the assignments you're going to do today. So here we go, laws of stratigraphy. So this is talking about sedimentary rock layers. And so there's the definition for stratigraphy right there. If you haven't reviewed it yet, it is the study of rock layers. Rock layers are formed from the bottom up, which means that the oldest rocks are on bottom and the youngest are on top. And this kind of makes sense if you think of just like a blank slate, and then along come some sediments. Those settle in, get compacted and cemented together, and then another layer of sediments comes on top of that. They get compacted and cemented together, and then another layer comes on top. They get compacted and cemented together. So the ones that are on bottom are the ones that formed first, which means they're the oldest, and the youngest, or the current layer that's now forming, is the youngest layer. And that is the basic of stratigraphy. That is actually called the law of superposition. So superposition says that the oldest layer is on the bottom, the youngest is on top. And so you guys took a quiz earlier. We learned about relative ages of these layers. And the quiz kind of messed around a little bit, tilted the layers, and showed that even when the layers are slightly tilted, still the oldest one is on the bottom, the youngest is on top. For the youngest to be on bottom and the oldest to be on top, you would have to completely flip the layer upside down, which might happen sometimes, but that's very unusual. And so this helps us determine relative age, meaning that we can't determine exact age. So we can know that, for example, the fossil on the bottom here is older than ones above it, which is older than one above that, and so on. So we can, like this seashell looking thing. I'm trying to see if you can see my cursor or not. Maybe not. Anyway, the seashell, the one in the blue layer, would be older than the crawdad looking thing, but younger than the spiral thing in the red layer. So that's the law of superposition. Next, we have, oh, sorry, we're not there yet. So law of superposition also helps us determine something called the geologic timeline. Basically, the deeper we dig, we understand that basically we're kind of traveling through time, but with rocks. So the oldest rocks would be at the very bottom. I'm not going to go over every single one of these layers, maybe in a future lecture, but not right now. This is just talking about the general geologic timeline. In other words, looking at the different time eras as they correspond to rock layers. Like I said, this is a topic for another video, but the law of superposition helps us understand the ages of these rocks. Right, law of horizontality. So when rock layers are first formed, they form horizontally. And let me just pause here real quick to say that if you have a question as you're listening to this video, feel free to leave a comment in the comment section below. I do look at those and I will respond if you guys have questions about that or anything you see here. Anyway, law of original horizontality says that when laws are first deposited, they're deposited in flat or horizontal layers. So if they're tilted or compressed or curved, that must have happened after these layers were deposited. So here on the background here we have a sedimentary rock layer, some rock strata, and most of them are horizontal, except that there's this little kind of bump right there that's called a fold, kind of like an upside down bowl. And that was the layer of original horizontality. So when rock layers are first laid down, they're laid down in flat or horizontal layers. Then we have the law of lateral continuity. This is one of my favorites. This says that matching rock layers were deposited at the same time, so they are the same age. So here we have like a canyon, and maybe in this canyon, a river has worn down through these rocks and made a path for itself. Well, it's kind of destroyed rocks on either side, but these rocks have the same spacing or the same color in this example and the same height. So we know that they're the same layer and they were formed exactly at the same time. It's just that the erosion has separated them. Same with this picture on the left. There's some water here, or some gap, some valley that's formed, but we know we can if we find the rock layer on the left is 1,000 years old, that means the rock layer on the right is also 1,000 years old. The rock layers match, so they must form at the same time. This doesn't work. This works also for some. If you guys remember learning about Alfred Wegener used this in his theory of continental drift. He found matching rock layers in South America and Africa, which tied the two continents together, meaning that they were both formed at the same time, and they were once joined continents. So this is something that Alfred Wegener used in his to support his hypothesis of continental drift. So law of lateral continuity says that if you have matching rock layers, even if they're separated by a gap, they must have formed at the same time. Then law of cross-cutting relationships. This one's a little bit different because usually we say that the oldest layer is on bottom. But this is a special case where we have something like a volcanic eruption or magma chamber taking place. This says that rock layers may have another rock cutting across them, like igneous rock or a fault line. So yeah, this also works for fault lines. But here we have our normal rock layers, the oldest at the bottom, then the youngest sort of is at the top. But now there's this little weird dark spot here. This is called an igneous intrusion. This is like an old cooled down magma tunnel. So because this rock, because that volcanic rock cuts through all the ones above it, it is the youngest rock. So the youngest rock is right there. Because it cuts through all the other rock layers. That's why it's called cross-cutting relationships, because anything that cuts through rock layers that was there before it must have been the youngest event or layer. I say event because let's say if this is a crack and not a volcano eruption. If this is a fault line, that means the rocks were shifted after the layers were put down. So let's do some examples together. Oh, nope. Sorry. Here's an actual photo of a cross-cutting relationship. This is an actual cool down lava cutting through all these other rock layers that were already there. So like normal, the oldest at the bottom, youngest at the top, except that really the youngest rock is the one that cuts through all the other ones, that igneous intrusion. That's called a cross-cutting relationship. Same with this unconformity. This is another cross-cutting relationship here. So we have this weird tilted rock layer, and then on top of the tilt, we have 4 more layers. 1, 2, 3, 4. And so the youngest layer is the one on top, but the tilt happened right before the 4th layer down. So we have youngest, younger, a little bit younger, a little bit younger, but then the tilt happened after these, what, 1, 2, 3, 4, 5, about 7, 8 layers were formed. And here's an example on the left, a photo of, you can see this big tilt here, and then after the tilt, more layers were added on top. So the tilt came right before the deepest flat layer there. Index fossils, I think you read about this in the CK12. Index fossils are very handy because these are animals that lived for a short amount of time all over the world and then died really about the same time. And so those animals, because they have such a short lifespan, we can almost pinpoint exactly when they must have died. And so we can tell exactly how old rock is. So index fossils are very helpful to help us date certain rock layers. But we're not going to go over index fossils in this one. So in this one, this is, you guys are going to get a few charts that look like this, and you have to determine when these events took place. So number these layers or events from oldest to youngest, 1 through 5. So I'm going to let you pause the video here if you want and see if you guys can get it. And we'll go over the solution in just 1 minute. All right. So sometimes easiest to start from the oldest rock layer, going from the bottom to the top. So C is the oldest layer. by the law of superposition, it was deposited first. So I'm going to say that oldest to youngest, one being the oldest because it happened first. And then the next oldest, well, B was put on top of that. Kind of ignore this fault line for a second. Well, maybe it's kind of easier if I just explain the whole thing. So you can see that C, B, and then A was put on top, and then everything was shifted out of place. Oh, and A was shifted out of place, B was shifted out of place, and then you have this weird D thing. We'll talk about that too. So everything was shifted out of place by this fault line. So we know this fault line is the most recent event because it shifted everything out of place. Cross-cutting relationship says that the event that cuts through all the other layers is the youngest layer. So it cuts through. If it didn't shift A out of place, if it only shifted C and B and D out of place, then A would be the youngest. But in this case, it shifted all of them. So that is the youngest, so 5. Okay, so going back to C being the oldest, B is the next oldest. Oops. So 2 for B, and then 3A is happened after B was laid down. So layer C was laid down, layer B was laid down, then layer A was put down. And then, okay, how do we know that D is 4? Because that's the only choice left. Well, D happened fourth because we can see that it cuts through C, B, and A, but also E moved it. So D used to be connected until that fault line E happened. Everything kind of shifted down, like there might have been some big earthquake or a series of earthquakes that caused the whole rock layer to shift diagonally down. So again, just to review this problem, because you guys are going to do a few like this. C happened first. It was laid down first, and then B, and then A, and then D is a igneous intrusion that cut through all of them. Cross-cutting relationship says whatever it cuts through is the youngest, but then something else cut through the intrusion and the other 3 layers. That's the fault line right there, which shifted everything down, which means E is the most recent event. So I hope this video helped you guys understand the laws of stratigraphy and help you understand how to do an example like this one. Feel free to watch this as many times as you need to. And yeah, if you have any questions, always reach out to me. It's been a pleasure teaching you guys. I will talk to you later. Bye. Stop recording. Stop.